Hello everyone, my name is Yu Chen Li, a master degree student from National Kaohsiung University of Science and Technology of Electrical Engineering. The subject of my presentation is protected health information recognition of unstructured call mixes electronic health records in Taiwan. First, I want to brief introduce of our motivation. For medical purpose, if the EHR were used for other purpose, personal information should be removed and changed to PHI, which is defined by GDPR and HIPAA. What is de-identification? De-identification is to remove the privacy of the PHI part and replace it with the new purpose. Considering of manual de-identification of larger block of EHIs is prohibitively expensive. Automated method is needed for large-scale de-identification. Physicians in Taiwan usually write notes in the mixing of English and Chinese languages, referring to as the problem of co-mixing. Co-mixing causes problems for many language processing systems. They are based on the particular language model, represent the construction of the identification corpus and investment, the efficiencies of the application of state-of-the-art entity recognition methods to de-identify PHIs mentioned in unstructured medical records in the manner of Chinese-English co-mixing. Next, I want to explain our dataset and how we develop our systems. With the proof of the research L6 committee of the National Taiwan University Hospital, the EHR data sampled from the psychiatric unit of the NTUH integrated medical database were used in our research. We randomly sample 800 summarized as the final dataset. We hired 4 annotators who know both English and Chinese to use the tool to annotate the dataset. They follow the above guideline to annotate an identical set of 200 randomly sampled records. Afterwards, a meeting was organized to discuss issues and concerns encountered during the annotation. This table presents the statistics of the final datasets used in our study. We use 600 remaining summarized as our training set, and the test set is 200 shared summarized. We have defined 21 types of PHIs, which are more complicated than those defined by GDPR and HIPAA. If you pay attention to radio PHI and non-PHI tokens in the dataset, you will find the invariance radio is extremely. And what is called co-mixing index? When comparing different co-mix corpora to each other, it is describable to have a measurement of the level of mixing between languages. At the sentence level it can be regarded as finding the major languages in the sentence and then counting the frequency of the words belonging to all other languages. We use the following co-mixing index CNI formula, which defined by measuring the complexity of co-mixing this paper to measure the level of mixings between English and Chinese in our corpus. Here we use a sample example to demonstrate the CNI value. Next to each word is language. EN is English, ZH is Chinese, UNIV is number or punctuation. Co-mixing index calculated by the formula is 32.8. We formulate the text as a sequential labeling text and apply the BILU encoding method. So taking a picture both as an example, if it is a set of continuous words, it will be represented by BIL. B represent for beginning, I represent the middle, and L represent for last, and U is a single word. And this is our method to apply the test. The first is dictionary-based approach. The algorithm assigns each word with the most prevalent label observed in the training set. In case the word is of vocabulary, the all label will be assigned. And the second is conditional random field (CIF). The CIF algorithm was implemented and trained with the following feature. We selected three word features, half speech, autolocal features. And the third is bidirectional long short-term memories, bidirectional LSTM plus CIF. The neural network method includes an embedding layer followed by a bidirectional LSTM layer to capture the long-term dependencies, and a CIF layer to determine the best labeling sequence. And the final is BERT-based models. BERT is a language model based on a bidirectional encoder of transformer, which broken several records of language-based tasks. We use BERT-based case, BERT Chinese, and BERT multilingual. The reason why we choose both models is that our dataset contains Chinese and English mixed text, so we would like to see the effect of transferring the pre-trained multilingual BERT in our test. This page introduces our hyperparameter of our model. This page introduces the evaluation formula. Next, I want to show you the performance of our systems on this dataset. The table shows the results of the improvement method on the test set. The F-score of the dictionary-based method is lower than 1.5, 0.5, which may be owing the reason that we didn't compile comparison PHI dictionaries. For all PHI types, we only collect the dictionary from the training set. All the machine learning-based models achieve satisfied micro F-score over 0.9. Next is discussion. This table shows the CNI for training and test set. The calculated CNIs of the training and test set are around 10%, comparing with the CNI values of English and Bengali is around 5%, and Dutch and Turkish are around 4%. In chatbots, which are measuring the complexity of co-mixing, the mixing level of our corpus is high. Please note that there are no sentences only contain Chinese in our data set. We separate the sentences in the test set into sentences without co-mixing and sentence contain co-mixing words to examine the inference or co-mixing for the test PHI recognition. The picture above shows the results of the performance comparison. You can find that there are a few types of PHI in English, and these are more types of PHI in English and Chinese with lower scores. This shows that co-mixing does cause the identification difficult. All supervised learning methods perform better in the set of English sentences, but their F-score dropped by 0.07 for CIF and bidirectional LSTM plus CIF around 0.05. For BERT-based models on the mixed sentences, in general, we observe the BERT-based model tend to perform slightly better in PHI types, described in the manner called mixing. For instance, the figure shows the distribution of the co-mixing for patient and ID number in the test set. We can see that for the patient PHI type, 86% PHIs are described in Chinese word only. In contrast, 99% PHIs are describable in English word only for the ID number type. By contribution to the pre-trained language models, the BERT Chinese and BERT multilingual models representative outperform CIF by 0.242 and 0.37 on patient. For PHIs in ID number, which were mainly described in English, BERT multilingual achieved a similar F-score 0.845 with CIF 0.881, but the F-score of BERT Chinese dropped to 0.675. The final conclusion. In this work, we have presented a contribution of the unique co-mixing dataset for the text of the identification of EHIs in Taiwan. The experiment results in reliability. The supervised learning method can reliably recognize most of PHI types, but for PHI types like person and patient, which tend to be described in Chinese or mixed languages, the state of the art pre-training languages models still have room for improvement. This serves as a stronger evidence that we still require the development of more robust approaches that can be recognize PHIs in a co-mixing manner. Thank you for your listening.